Hello, geometry student, and welcome to Areas of Regular Polygons. In this lesson, you'll be provided with some information about three types of polygons that are regular, but we're going to find the areas of those. You'll notice that in this problem, or that we will be using the formula area equals 1/2 AP, and we'll be discussing what those mean as we are going through problems. So let's go ahead and start working on those problems. All right, let's go to example number 1. So it says a regular octagon with a side length of 33 centimeters. Okay, so what we're going to do here is we're going to first establish the fact that a octagon or an octagon has 8 sides. So I can go ahead and write that n is equal to 8. So n just represents the number of sides. Also, we know that the side length of it is 33 centimeters. Remember that in any regular polygon, each side and each angle inside are all the same. So what we can do is we can go ahead and find the perimeter. And so to find the perimeter, we're just going to do the number of sides, which is 8, and times it by 33, and multiply those together. I'm going to get 264. So right now we know that the perimeter is 264 units. Remember that what we need is we need to eventually write the formula or find the formula of the area, which is 1/2 A times P. Okay. Now, what is this A? Okay, this lowercase a. That lowercase a is what is called the apothem. Okay. And basically, in any regular polygon, the apothem goes from the center of the shape to the midpoint of one of the sides. Okay, that's what it is. So the best thing to do, honestly, is we don't necessarily have to draw an octagon or anything like that. We just have to be able to draw a right triangle. So in order to do that, I'm going to draw a right triangle. So here that is right here. Okay. And here's my right angle. So you can see that. And so basically the apothem for this right triangle will always be in the vertical position. So that is my A. Okay. Also in your right triangle, you have an R. Okay. And the R stands for the radius. So I'll go ahead and just put that over here in our little tool box here. And then we also have on the bottom an X, and the X over here represents half of a side. That's half of the side length of the polygon that we're dealing with. The other thing that you could also do on your triangles is you can decorate this up here, the top, this top angle, and that top angle can be found by doing 1/2 times 360 over n. That's the number of sides. We've already established that n is 8 in this problem, so that's what we'll eventually have to put in into this equation or into this triangle. So now that's the general triangle that you'll be using throughout most of the, in fact, all the problems that we're going to do. So I expect you to actually draw those triangles, draw these right triangles with the information that is provided. Okay, so now let's get to the actual question. We already have the perimeter. We have that, and we also know that the side length, the number of sides is 8. So what I'm gonna do now is just gonna draw another right triangle for this problem. And what we'll do is we're going to put that the X is going to represent half of a side length. So basically in this case, since X is half of a side length, I'm gonna write X equals half of 33, because it says each side is 33. So it'll be half of 33, and that's going to equal to 16.5. So therefore, I can put 16.5 down here for this side. Then the next thing I can do is I can find the measurement of the angle up here, and that's doing that by doing 1/2 times 360 divided by 8, because that's how many sides it is. And half of 360 divided by 8 is going to be 22.5. So 22.5 degrees. Now, because we have that 22.5, we can now find this angle down here by doing 90 minus 22.5. Remember that in the right triangle, besides the right angle, the other two angles are equal to 90 degrees. They are complementary. So we have 22.5 degrees for this angle. We have 90 minus 22.5, which is 67.5, okay? And then we're going to also establish that the A, which we need, is not known yet. So we're going to go and put that here. And we can also put R here, but as you hopefully know, R is not going to be used for this problem. So now what we'll do is, since we are looking for A, notice that A is opposite the 67.5 degree angle. What that means basically is I can write my arc right here and then just go across like that. And that's going to be my opposite side. The 16.5 that we have here will represent the adjacent side. Now the R that we have, again, no need for it. So that's what we have. So we have A is our opposite, 16.5 is our adjacent. And so at this point, what you'll do is you'll just do our trigonometry. And remember the acronym we use is SOHCAHTOA. And because we have the opposite and the adjacent that have meaning in this problem, that means we're going to look at our SOHCAHTOA and we see that it's going to be the opposite over in the adjacent. So there's tangent, okay? That's what the T stands for. So tangent, opposite over adjacent. So now all we have to do at this point is set up our proportion. So we're going to have the tangent of the angle that we use, which is 67.5 degrees, all over 1, which is equal to the the opposite, which is going to be A, over the adjacent, which is 16.5. Now, we're going to cross multiply. We're going to have A times 1, which is just going to be A. We're going to multiply 16.5 to the tangent of 67.5. And so now all we have to do is calculate what that is. Remember, of course, make sure that your calculator is in degrees when you're doing trigonometry. I have people that use Desmos. I have people that use a TI calculator. I even have one young lady that uses their iPhone calculator, her iPhone calculator. So just as long as your calculator is in degrees, it's okay. So I'm using my TI-84 calculator. And so basically, I'm just going to use my calculator and multiply 16.5 times the tangent of 67.5. My calculator is already in degrees because I've done this video before today and it wasn't recorded. That's why I'm doing it like this. So, but anyway, 16.5 times tangent of 67.5 is approximately 39.83, and it's a 4, so we'll just keep it at 39.83. So A is approximately 39.83. Okay, so now since we have the apothem, that's A, we already have the perimeter, that's here. So all we got to do now is just use our formula to come up with the area of this polygon. So all we got to do is write area equals 1/2 times the apothem times the perimeter. That's the formula. And so that means that we can write area is approximately 1/2 times the apothem, which is 39.83, and times it by the perimeter, which is 264. Once you have all those filled in, once you have those values filled in, you can go ahead and put that in your calculator. Again, I'll use my TI-84. So you're just going to do 1/2 times 39.83 times 264, and you get approximately 5,257.56. Okay, and that's going to be my area of this regular octagon. So this is the steps that you'll do when you are given the side length, okay? The angles will change because it might be a different shape. Obviously, the side length will change, but this is basically the concept that you would do to find the area of a regular polygon when you're given the side length, okay? Okay, we're now ready for problem number 2, which talks about a regular nonagon with an apothem or an apothem that has a length of 13 units. So again, it's not necessary for you to draw an apothem. Well, it is, but it's not necessary for you to draw a nonagon. Okay, but what we do need to do is we do need to establish that a nonagon does have 9 sides. So I'm going to go ahead and write that n is equal to 9 because of the nonagon. We also know, again, the apothem, which is going to be 13 units. So I'll just put A equals 13. And so at this point, what we'll do is we'll go ahead and create our right triangle, because again, all we need is that right triangle. And what we are going to do is we're going to fill in A. So A is 13. Remember, the apothem will go on the vertical side like that. X, we do not know, will be down here. And again, this is going to be R. And as you'll find out, R is not going to be necessary to be found. The other thing we can also do is we can go ahead and establish how many degrees this angle is here. Remember, we do that by doing half times 360 over the number of sides, which is going to be 9. So half times 360 divided by 9. So if you put that in the calculator, you'll find out that that value is going to equal to 20. So this angle here is 20 degrees. Because this angle is 20 degrees, that means that this angle here will be 90 minus 20 degrees, which is going to be 70. So we have our angle set here for this triangle. Now, remember our formula for area. Our formula for area is 1/2 times apothem times the perimeter. And so then basically what you'll do is you're going to find the, like I said, it's going to go and find the value of the apothem, and which we already have, but we're going to try to find X is what we need, because we need to find the perimeter. Yeah. Okay. So basically what we'll do is we're going to do that by doing trigonometry. You'll notice that the X is on the opposite of 20 degrees. So I'm going to put 20 degrees as an arc, and I'm going to point that across to this side, and that's going to represent our opposite side. The 13 that we have here is going to represent the adjacent side, and then we have the hypotenuse for the radius. But again, we don't need the radius because it's not part of the formula or anything like that. So with X being our opposite side and 13 being our adjacent, we again can write down the opposite, the SOHCAHTOA for our acronym. And because we have that, what that means is we're going to fill out the fact that X is the opposite and 13 is the adjacent. So that means that, again, we will be using tangent. So we'll use a tangent. And so we're going to fill out the angle as the tangent of 20 degrees over 1 equals the opposite, which is X, over the adjacent, which is 13. We're going to cross multiply X times 1 to get X. We're going to cross multiply 13 times the tangent of 20 degrees, and we get that right there. All right. And so again, we'll just use our calculator to multiply. So it's going to be 13 times the tangent of 20 degrees. And if I do that, I'm going to get approximately 4.73, because it's 4.731. Okay. Remember that X represents half of a side. So I'm just going to put that here. And since I know that X is half of the side, that means that I can find the whole side by multiplying 4.73 by 2. And so with that being said, I can just go to my calculator and multiply 2 times 4.73 and get approximately 9.46. And that's how long one side is. Now, because I know how long one side is, I can now find the perimeter, and the perimeter simply just means that I can multiply one side by how many sides we had, which in this case was 9. So the perimeter is going to be 9 times 9.46. And so that's going to equal to, using my calculator, 85.14, or approximately 85.14. So therefore, the perimeter is that value, 85.14. And since we have the perimeter, underline that, since we have the apothem, we have that, we can now use our formula, our area formula. That area equals 1/2 times apothem times the perimeter. So that means we're going to, I'm just going to rewrite it. Area equals 1/2 times the apothem times the perimeter. And so we're just going to fill it in. So A is approximately 1/2 times the apothem, which is, if I can just move this out of the way for a moment, there we go. The apothem is 13, so we put 13, and then we're going to multiply that by the perimeter, which is 85.14. And all I gotta do again is just use my calculator. So multiply half to 13 times 85.4, and I get approximately 553.41. Okay? And I got that in rehearsal, so I think I'm good. Okay, the made up rehearsal that I had. So, but anyway, that is the area, and this is a process that you use to find the area of a regular polygon when you are given the length of the apostle. Okay, you see, we're still using tangent. We just changed our perspective on the angle. So, there's that. All right, we're on to example number 3. We have a regular pentagon with a radius whose length is 27 units. So again, we're going to determine what we are given. So one thing that's given is the fact that this is a pentagon that we're going to deal with, and that pentagon, of course, has 5 sides. So therefore, n is equal to 5. We also know the radius, and that's equal to 27. As hopefully you've been paying attention to throughout this video, you'll know, of course, that the area of a regular polygon does not involve the radius. What we can do is we can find the parts for it to help us find that area. But in order to do that, we're going to start off, of course, by drawing our right triangle. So that's what we'll do at this point. So here's our right triangle. We know, of course, that the vertex, the vertical side is our apothem. So I'm just going to put that as A. We also know that the base of this right triangle is going to be my x. Remember, x represents half of a side. And of course, this hypotenuse is r, and we do know what r is this time. R is 27. Okay, so there's our sides of this right triangle. We also can go ahead and figure out how many degrees our angles are inside the right triangle, the other angles. And so remember, to do that, we're just going to take this angle. We're going to do half of 360 divided by the sides we have, which is going to be 5. So half of 360 over 5. And that's going to equal to 36 degrees if you use your calculator. So 36 degrees. The value of this angle here will be 90 minus 36, which of course is going to equal to 54. And I had 54 for dinner over the weekend. Okay, the taping of this video. Okay, and so A is 50, that angle is 54. And so now we just need to figure out what the values of A are and what X is. Okay, X, A, and X. What we got to figure out what those are. Now, so that means we basically have to do trigonometry twice because we have 2 unknowns and we need to know both of them. So what we're going to do is we're going to, of course, write SOHCAHTOA. And what we're going to do now is we're going to establish the fact that I think we should find A first. It's a little easier to find for our formula. And so to find A, what I'm going to do is, since A is opposite the 54-degree angle that we just got, I'm going to use that as my opposite side. And so A is opposite at 54 degrees, so put opposite. We know that the X is going to be the adjacent, which we may use later on. And then, of course, R equals 27 is the hypotenuse. Okay? Now, because we're looking for the opposite side, and we already have the hypotenuse, that means that we need to look at our SOHCAHTOA, and we see that the one that uses opposite hypotenuse is going to be sine. So therefore, we're going to put, we're going to circle that part, and now we're going to set up our proportion. So we're going to have sine of the angle, which is 54 degrees. We're going to put it over 1, and it's going to equal to the opposite, which is A, and the hypotenuse, which is 27. And now, because we have done this already, we're going to cross multiply. So we're going to cross multiply A times 1, which is going to be A. We're going to cross multiply 27 to the sine of 54 degrees. Okay. And once again, just make sure that your calculator is in degrees. My calculator is. So you're just going to do 27 times the sine of 54. And you're going to get approximately 21.843. So we're going to keep it at 84. So A is approximately 21.84. Okay, so we have established, or we have found our apothem. So I'll go and underline that. Now, the next thing we'll do is we're going to find the X. Now, X is the adjacent side, but we already have the hypotenuse. And the rule of thumb about trigonometry is always use what's given to you. Don't use a value that you have just found. So we still have the 27 for the hypotenuse, and we can just use x because we're looking for the adjacent. So therefore, we have adjacent, we have a hypotenuse. So in our trigonometry, that tells us that we must use cosine. So I'm going to go ahead and do that a different color, all right? And then now I'm just going to write that part here, which is going to be the cosine of 54 degrees. It's still the same angle, all over 1 is going to equal to x over 27, okay? Again, we'll cross multiply. X times 1 is just x. 27 times the cosine of 54 degrees. Now, all we have to do is cross multiply 27 and cosine 54. So basically, we're just going to do 27 times cosine of 54, and we're going to get approximately 15.87. It's a 0 after that, so just keep it at 15.87. And so now the next thing we'll do is, since x, remember, is half of a side, I'm just going to put that, I guess I'll put that over here. So remember, x represents half of a side. So that means that we can find a whole side by taking the x and multiplying it by 2. So that means one side is equal to 2 times 15.87, and 2 times 15.87 approximately is going to be 31.74, okay? So that's our one side. But since we have our one side, we can now find our perimeter. And remember, to find the perimeter, we just multiply one side length to how many sides we had. In this case, there's 5 sides. So that means that when I write this, I'm gonna have, let's see, does this look good? I guess it looks all right. So no, I'll use a different color. So we got P is approximately 5 sides, right? So we have 5 times 31.74. And then we're just gonna multiply those two numbers, and we're gonna get approximately 158.7 and then 0, because I like to round things to the nearest hundredth. Okay, so we have our perimeter, 158.70. And so now we have our perimeter, we have our apothem. So now it's time for us to find the area. And so let's do that. So let me section this off. We have our area, which is equal to 1/2 times the apothem times the perimeter. So that means area is equal to 1/2 times the apothem, which is 21.84, and multiply that to the perimeter, which is about 158.70. This should be approximates, by the way. So now just use our calculator. So 1/2 times 21.84 times 15 or 158.70, and you're going to get approximately 1,733. Now on my calculator, it's 0.00. And I'm asking you, because we are supposed to round to nearest hundred, to go ahead and write that 00. Okay, so even though, yeah, it's 00, we can just write, oh, it's 1,733. You have to still show that it's rounded to the nearest hundredth. And remember, we did some rounding earlier in the problem, so we're gonna show that decimal, those decimal places, and that's what we got. So 1,733. So that's our area, and so I'm just going to box that in and make sure you have that 1,733.00, and that's how we have found the area of this pentagon. So like I said, in this particular problem, calling this like a level 3 level, or example 1 was like a level 1 problem. Example number 2 is a level 2 problem. This is a level 3 because you had to find 2 unknowns for our formula. And so this is just how you would do it when you were given the radius. So you got to work backwards to find both the A and the X. Then, of course, use that X to help you find the side length, help you use that to find the perimeter. And then once you have the perimeter and the apothem, then you can plug it into our area formula. Okay? All right. So thank you so much for watching this video. This is usually something I don't do, put myself on screen. So hopefully, you know, if you like it, if you like that, then I'll be glad to do this from now on. If not, I'm willing to not have myself shown. But please feel free to comment, like, just anything for this video. And I just look forward to seeing your work on problems like this. We are going to have some problems with this, and you could probably have a test over this at some point. You might have to do this on a standardized test at some point, whatever. Just looking forward to seeing the good work that I know that's going to happen based on you seeing this video. So until next time, take care and have a great day.